All right, hello everyone. So today we're moving ahead. We're working on our 5.11 notes. We're determining whether a point is a solution to an inequality. And you see we're going to do that first using the inequalities where we don't see the graphs. We just know the inequalities. We know the point we're checking. And then we'll look and see how it works if we can actually see the graph. So if you're determining whether an ordered pair is a solution or not to a given system, we're going to replace the x and y values with these xy coordinates, and we're going to see whether it satisfies both inequalities. So I'm going to start with the y less than 2x plus 4, and I'm going to substitute y is 11 less than 2 times x is 5 plus 4. And then I get 11 less than 2 times 5 is 10, 10 plus 4 is 14, 11 less than 14 is true, so I'm just going to check that off. But I'm not going to make any final decisions till I also check the other inequality. And that was y greater than or equal to negative 3x plus 1. So I'm again substituting y 11 greater than or equal to negative 3 times x is 5 plus 1. That's 11 greater than or equal to negative 15 plus 1. And that's 11 greater than or equal to negative 14. Absolutely true. Check that off as well. Allows me to give a final answer of yes. So yes, 5, 11 is a solution to that system. And then I'm going to check negative 5, negative 7. So I go back to the first inequality. I replace y with negative 7. And then 2 times x is negative 5. That becomes negative 7 less than negative 10 plus 4. That's negative 7 less than negative 6. And that is a yes, it's true. Check it off. And then I go to the other one, and that's y greater than or equal to negative 3x plus 1. Replace y with negative 7 greater than or equal to negative 3 times x is negative 5. Plus 1, that becomes negative 7 greater than or equal to 15 plus 1, that negative times negative made a positive, and that becomes negative 7 greater than or equal to 16. Of course, negative 7 is not greater than 16, so I'm going to X that one out, and that's a no. If it only works for one of them but not the other, then no, it's not a solution to the system, because a solution to the system will satisfy both of them. Now, over here you can see it's the same inequalities. It's the same points that we're checking, it's just on a graph now. Unfortunately, the points they chose for this, well, one of them falls off the graph. In fact, the other one does too, just not by as much. So for this one, when we check whether it works on a graph, we're just seeing, does this point fall in this shaded region? We know it had to be like above this line. So there's points over here that are above this one, but they don't satisfy below that one. So it also had to be below this one, and that's over here where it's below this one, but not above. So you get this double region. And we're just checking, does 5, 11 fall in that region? Well, if I go up 5, over 5, and up 11, again, this is where it's a little problematic. It runs way off the graph. Now, we know from before that it does work, and you can kind of extend this line, show where it would go, extend this line. It's a little complicated, but it would fall somewhere right up here, and it would be in that shaded region still. So that is a yes. Again, it's just, does it fall in the shaded region? Now, left 5, down 7. When I go left 5, down 7, it's clear, even though I'm off the graph, I'm nowhere near that shaded region. And that's a no. So you see, we still get 5, 11 as a yes. We still get negative 5, negative 7 as a no. I'm going to skip the 3 examples at the bottom here. I refer you right back up here. It's the same thing. They just have us do it over and over. So if you take an ordered pair and a system of inequalities, check one, check the other. It needs to work for both of them to say a yes. If even one of them doesn't work, then you say no. So again, some extra examples down here we're going to skip. On page 56, I do, however, want to do this extra graph, because even though it's similar to the one we just did, for starters, these points actually fit on the graph, and there's something about what we see on here that's a little different. So let's start with left 3, up 3. Remember, we're checking, does it fit in the shaded region? And when I go left 3, up 3, there's that point right there. It is obviously right inside of that shaded region. That's all it takes for me to say yes. Now when I check right 1, down 2, When I go right 1 down 2, you notice this falls on one of the lines. That's why I wanted to see this example a little different. So if you went underneath this dotted one, it's under there, and then you had to go above that solid one. Well, it's not above there, it's on it. And this is where the type of line is really important. Solid lines are part of the answer. So it's on the border of the shaded region, but it's on a solid line. That's a yes. Now check 1, 3, and you'll go right 1, up 3. You'll notice this is also on one of the lines. However, this time it falls on one of the dotted lines. So is it up above this solid line? Yeah, it definitely is. And is it down below this dotted line? Well, no, it's not below it, it's actually on it. The problem this time is a dotted line is not part of our answer. So that's enough for me to say no. So it either needs to be in the region, or if it's on a border, it has to be a solid border. If it's on a dotted border, then we answer no. Last thing we do in these notes today is look at a word problem where you had to spend at most $20, and we see this line represented the total cost, at most $20, and you could buy no more than 6 items, and we see this line represented the number of items. So we see the line for cost and how it had to be below that. So I'm going below the cost line. And then we saw that it had to be no more than 6 items. So I see the number of items, and I'm staying below that as well. And now we look at these 4 regions. And what we notice is there's one region right here that has my blue lines and my green lines. It was below both of them. Well, what does that mean? It means any point in here is both. Anything in region 1 is both less, at most $20, both at most $20, and no more than 6 items. When we look at region 2, I notice I only have the blue lines. That means it's underneath the line for number of items. It is no more than 6 items. But you see it's above the cost line. So even though you're getting no more than 6 items, you're spending too much money. But not at most $20. Now in region 3, it's the opposite. We see the green lines only. That means it is underneath the cost line. It is at most $20. But what I notice is it's above the line that represented the number of items. So now you're getting too many items. You're getting more than 6 items, but not no more than 6 items. And finally, region 4, there's nothing. And that means it didn't satisfy either one of these. So this is not at most $20 and not no more than 6 items. All right, so that's all for our 5.11 notes. Now today you're moving on. You're also working on your 5.11 RSG, but only a few problems. You're working on numbers 1 through 3. So just 1, 2, 3, and then you're skipping ahead, and you're doing the last few problems. You're doing numbers 10, 11, 12, as well as over here number 13. So you see you've got a few examples where you're checking using the inequalities like what we started with. You've got a few examples where you're checking on a graph like we did next, and then just one example where you're describing the 4 regions. Remember, for that one, try to go back to this and see how the 4 regions are telling you it's either both, or only one, or only the other, or maybe it's none of them. When you upload your work today, you don't have to upload these notes. Instead, please just upload the work you do. So I just need pictures of 1, 2, and 3 on page 57. That's right here, 1, 2, 3 on 57. pictures of 10, 11, and 12 on page 58, and a picture of number 13 on page 59. Thank you very much.